Hello everyone, welcome to the session of actual questions of AP and TG ICET numbers topic we will be focusing on. Before we start, let's look at the questions. Before we start, please subscribe to our YouTube channel Time for ICET to get latest updates and videos for your preparation. Let's look at the first question that was given in the examination. For what values of x and y, the 6-digit number 7x342y is divisible by 88. So when we can say that a number is divisible by 88 is the first point that we have to know here, right? So for divisibility rules, we will be using the co-primes concept, right? 88, if we write it as 8 and 11 multiplication, we will be getting 88, we can say. 8 and 11 are basically co-primes, right? And when we can say that a number is divisible by 88, when the last 3 digits of a number, if it is divisible by something like ABC, if they are the last 3 digits of the number, if it is divisible by 8, that part, then we can say that the entire number is divisible by 8. And for 11, what is the rule that we are having? It is basically difference between sum of the digits in odd places and those in even places. That difference should be basically divisible by 11. Difference between sum of the digits in odd and even places. This has to be a multiple of 11. These are the things that we have to know for answering this question, right? So if you just look at the number given to us is 7x342y. So first we will focus on divisibility by 8. What is the rule? Last 3-digit part should be divisible by 8. What is the last 3-digit part? Here we are having 42y. And we know 8 5s is 40 or 8 50s is 400. So now what we can say, 400 plus some extra number that we are having, which is 2y. So what we can say, if you are looking at multiples of 8, we know 24 is basically divisible by 8. So that means what we can say, y if it is 4, this number becomes divisible by 8, we can say, right? So there are two options which are focusing on y as 4, choice 3 and choice 4. So one of them will be our answer, we understand. And for divisibility by 11, the rule that we are having is what? The difference between sum of the digits in odd places and those in even places. I'm taking directly y as 4 there, right? So now if you are observing, sum of the digits in odd places will become basically 4 plus x, which is nothing but 8 plus x, we can say. And sum of the digits in even places is what? 2 plus 3 plus 7, which is nothing but 12. And we have the difference should be either 0 or multiple of 11. So 8 plus x, if it is difference is equal to 0, that means 8 plus x should be equal to 12. In that case, what we can say, x will become 4, 12 minus 8. So x should be 4 and y should be 4. Then that number will divisible by both 8 and 11. That means, in other words, it will become divisible by 88. Right? Slightly lengthy question, but definitely doable question if you know that rule, divisibility rules. Let's move on to the next question. The question is in this way. The least common multiple of two prime numbers a and b is 319, where he has mentioned in the brackets a is less than b. Then 5a minus 8b is how much is the question, right? So if you are observing carefully, they are given to be prime numbers. A and b are given to be prime numbers, right? So for two prime numbers, LCM will be always equal to their product. LCM will be always equal to their product. Suppose if you are considering numbers like 3 and 7, what is the LCM of for 3 and 7? We can say 3 7s 21, because up to that there won't be any common multiple that we'll be having. So in the same way, in this particular case, LCM of a and b is given as 319. So that means, in other words, what we can say, a into b3 should be equal to 319. And if you observe carefully, 319 is clearly divisible by 11, because 9 plus 3 is 12, 12 minus 1 is 11. As 11 is divisible by 11, that number is divisible by 11, we can say. So if you are observing carefully, this is 11 multiple. 11 to 22, 99 means 9 times it will be going. So what we understand, a into b should be in the form of 11 into 29. As a is mentioned as less than b in the brackets, a should be 11 and b should be 29, right? What we have to find out, 5a minus 8b is how much is the question. So 5a will become 5 into 11 minus 8b will be 8 into 29, right? 5 11s is 55. Had it been 8 30s, it would have been 240. But మనకి ఇక్కడ 29 times ఉంది. 8 30s అయితే 240 got 1 time less అంటే ఎంత తక్కువ? 8 తక్కువ. It should be 232. So if we consider this as basically 240 minus 55, what we can say, it will be 187. But now 5 పెంచాం కాబట్టి it should be 177 we will be having. So answer should be what? Minus 177. 232 minus 55 will be. 55 minus 232 will be negative number 177 will be having. Okay. Let's look at the next question. Sum of the digits of the largest 4-digit number exactly divisible by 77 is. So if you are observing carefully, largest 4-digit is nothing but 9,999. Antena? That if it is dividing by 77, we get some remainder. Sometimes it may be exactly divisible also, right? So if you are having remainder, subtract the remainder to get the multiple of 77. 77 once is 77. We will be having 2 here, 229. Right or not? 77 3 times if we consider, it will become 231 because 73 is 210. 3 more times and take 21 up 231, it crosses. So that is the reason we cannot go for 3 times. We have to go for only 2 times. So 2 times is going to be 154. Right. So how much is the gap between these two? Now we can say 5 here, 7 here, it will be 759. So what we understand? 9 times it will be going there. 77 tens will be 770. 759 and 9 times it will be going. 9763 we will be having 6 carried, and 9763 plus 6 carried will be 693. So how much is the gap between these two? We can say ila subtraction chesadu manaku 9 minus 3 directly it is 6 we can say there, and 75 minus 69 will be 6 we can say. So now what we understand, 9,999 if we divide by 77, there is a remainder of 66. So in other words, what we can say, 9,999 minus 66, 9,933 is divisible by 77. మనకు కావాల్సింది ఏంటి? Sum of the digits in that particular number. So 9 plus 9, 18, 3 plus 3, 6. So 18 plus 6, it will be 24 is the sum of the digits. This is the actual way of getting the answer. But if you are observing carefully, we don't have to go for division of that 9th largest 4-digit number. If you are observing carefully, 77 13s if you are considering, what we can say, 77 10s is 770, right? 77 3s is 231. ఈ రెండింటిని యాడ్ చేస్తే మనకు వచ్చేది 1001, right or not? So that means if you are considering 130 times, it will be basically 1 0 extra will be having. That means it is crossing 10,000 by 10. So that means what we understand, the previous multiple will be the largest 4-digit multiple. So subtract 77 from this. So what we understand, carrying this one 0 this side, it will be 110 minus 70 means 33. 100 minus will be having 7 will be having 100 minus 1, that will become basically 99. So what we can say, it will become 9933. That is one more way of getting the value for the number, right? So this is an easy approach for getting the multiple there, right? Let's move on to the next question. If m by n is equal to 14.7 bar. So bar basically indicates that 7 is appearing continuously, where m and n are positive integers with no common divisors except 1. That means basically they are co-prime. Then 3m plus 2n is how much is the question, right? Okay. So m by n is basically in the form of 14.7 bar, he say. And we know from our speed mass calculations, 7 bar is nothing but, 0.7 bar is nothing but 7 by 9. So we can write it as basically 14 7 by 9. 14 9s వచ్చేసి మనకి 126 plus 7 133. So what we understand, it will be 133 by 9 is m by n, and m and n are not having any common factor. That means they should be in the simplified form. Already 133 by n is in the simplified form lone undi manaki, right? So now if you are observing, m is basically 133, correspondingly n is 9. What we have to find out, 3m plus 2n. So 3m value వచ్చేసి మనకి 3 into 133 plus 2n will be 2 into 9, right? So 133 is 390 plus 3 means 3 means 399. And what we can say 2 nines is 18. What we can say 399 plus 18 will become 417. So answer for this question should be choice 2, 417. Right? Only thing that we have to know is that this is what is the form of the number we will be normally expressing. Adi teliste manaki question, easy question. Let's look at the next one. Find the number of positive integers less than 100 which are not relatively prime to 100. Right? So if you are observing carefully, just a small example like this one. If you consider instead of 10, instead of 110, is 1 co-prime with 100 means 10 means yes. 1 and what are co-primes, by the way? Two numbers, if they have only 1 as the common factor, they are basically termed as co-primes, or also known as relatively prime. And if you are observing here, 1 and 10, they are not having any common factor. So what we can say, 1 will be co-prime with 10. 2 and 10, they have 2 as the common factor. That means they are not co-prime. If 2 is not co-prime with 10, any multiple of 2 will not be a co-prime to 10, we can say. So that means what we can directly say, ignore all even numbers then further. 3 will be co-prime. 5 and 10, they have 5 as the common factor. That means I can even ignore 5 also. 6 is anyway even number, ignore. 7 is co-prime with 10. 8 we can ignore. 9 is co-prime with 10. And 10, we are looking at less than 10 means what we can say? 1, 3, 7, 9. If it is a smaller number like this one, we can definitely go for counting them physically and looking at what are the numbers. But a bigger number like 100, if we go for this approach, we will be wasting our time. And again, we will look at the approach for this one. The approach is in this way. Whatever be the number given to us, then we will write it as product of prime factors. So 10 is nothing but 2 power 1 into 5 power 1. What are the prime factors that we have here? 2 and 5. Multiply the original number 10 with 1 minus 1 by first prime factor. Alane multiply with 1 minus 1 by second prime factor. So what we'll be having here? 10 into 1 by 2 into 1 minus 1 by 5 and 4 by 5. 2 5 is 10 kabatti 10 can be cancelled with 10. So what is the answer that we'll be having? 4. So these are the co-primes. How many numbers will be co-prime with 10, we can say, which are less than 10 means 4. In the same way, 100, if you are observing, what we can say, it will be 2 square, 4 into 25, 2 square into 5 square, right? So what we can say, these are the prime factors. And for finding the number of co-primes, indices are not having, the powers are not having any role. We can ignore them. So multiply 100 with 1 minus 1 by first prime factor, which is 2. Alane 1 minus 1 by second prime factor, 5. So what we can say, 100 into 1 by 2 into 4 by 5. So 2 5s 10 cancels with 1 0 here means 4 into 10 40. Manaku kavalsindi enti, find the number of positive integers less than 100 which are not relatively prime to 100. So relative prime are 40 we are having. So not relatively prime will be 100 minus 40 we will be normally considering. But ఇక్కడ just we have to be careful. What చెప్తున్నది including 100 or less than 100? It is less than 100 he is saying. So that means what we can say, we should subtract, even we should not consider even 100 also. That means only up to 99 we are considering. So how many numbers will be co-prime means 59 numbers will be co-prime, we can say. So answer for this question should be choice 4, 59 we can say. So in that way we can find the number of co-primes or relative primes to a given number. Let's move on to the next one. The number of positive divisors of 2025. So for finding the number of divisors also we have to go for prime factorization. So 2025 ni first we write it as product of prime factors. 25, what we can say, it is clearly divisible by 9 as well as, because 9 means some of the digits is 9 here, that is the reason it is divisible by 9. Anyway, it is ending with 5 means it will be divisible by 5 also. So first we will go for 5, which is easy to divide. 5 4s 20, 25 means 0 5 times. So 5 will be considering. 405 is clearly divisible by 5. How many times? 81 times. 81 is 3 power 4 we can say. If you write it as product of prime factors, 3 power 4 into 5 power 2. 5 power 2 is the prime factorization for this one. When we have the number expressed as product of co-primes, product of prime factors in this way, basically to find the number of factors, what we need to do is in this way. Whatever be the index for each of the numbers, add 1 to them, then multiply those numbers. ఇక్కడ మనకి ఇండెక్స్ ఎంత ఉంది 4 ఉంది. సో 4 plus 1 5. ఇక్కడ 2 plus 1 3. So what we can say, it will become 5 into 3 15. So how many numbers will be, how many positive divisors that 2025 will be having means 15 are the number of divisors for 2025. In that way, we will be finding the number of factors. So what we need to do, express the number as product of prime factors, add 1 to each of the indices and multiply them. That will give us the number of divisors. So let's look at the next one. The last digit of 7 power 100 is, and if you observe carefully, for any number, if you look at the successive powers, we understand that the unit digits are repeated in a cyclical order. Like powers of 7 only, if you are considering 7 power 1 enta 7, 7 square 49, 7 cube 343, 7 power 4 is nothing but 2401, 49 square. 7 power 5, if you are considering 2401 into 7 will be ending with 7, right or not? Will be ending with 7. So what are the numbers that we are having as the unit digits? 7, 9, 3, 1, 7. Next time again, 7 into 7 will be ending with 9, we can say. Into 9 will be ending, into 7 will be ending with 3. So that continues further. So what we understand, 7931, 7931, in that way we will be getting the cyclicity for the last digit of powers of 7. So what we understand, they are repeated after every 4 powers. That is the reason it is cyclicity, or cycle is mentioned as, is known as 4 here. So what we need to do is, once we know the cycle for the last digit of that given base, we should express the index in terms of the cycle there. Here manaki index enta undi 100 undi, cycle enta 4. So we should write 100 in terms of 4, which is 7 power 4 into 25. And after expressing this one, if you have any remainder, consider remainder. No remainder, cycle portion. As there is no remainder here, we consider only cycle portion 7 power 4. 7 power 4 is nothing but 49 square, which will be ending with 2401, means ending with 1, we can say. So answer for this question should be choice 2, right? So let's move on to the next one. The digit in the units place of 1 into 2 into 3 so on up to 183 plus 3 power 183 is how much is the question. ఇక్కడ మనం అబ్జర్వ్ చేస్తే 1 into 2 into 3 so on up to 183 లో we will have 1 2 present here, 4 5 is present here, 2 into 5 what, 10 into something will always end with 0. That means what we can say, this entire product will always end with 0 only. We don't have to worry about that one. So that means basically we are interested in the last digit of 3 power 183. And for 3 also, if you are observing cyclicity, the last digit part, what will be repetition will be having means 3 power 1 వచ్చేసి మనకి 3 square 9, 3 cube 27 means ends with 7, 3 power 4 81, 3 power 5 243. And one important thing is, once we get 1 as the unit digit, next time onwards we'll be finding the repetition will be there. Like the same case for 7 powers also, 7 power 4 2401, right? 7 power 5 will be ending with again 7. Same way ikkada kuda manaki after 4 powers it is starting repetition. So that means what we can say, 3 power 183 we should express in terms of cycle 4. So 445 is 180 plus 3 extra. So as earlier case we did not have any remainder, so మనం అక్కడ కన్సిడర్ చేయలే, but here we have a remainder, so we will be considering the remainder portion. So what we can say, 3 power 3 ends with basically what, 27. That means 7 power 183 will also end with 7. So answer for this question should be choice 1, right? So in that way we can answer the question, right? So let's move on to the next one. The remainder when 2 power 50 is divided by 5 is, this is also on the similar lines as that of the previous question, right? So when we divide successive powers of the same number with the same divisor, the remainders will be repeated. Like 2 power 1 if we divide by 5, remainder is what, 2. 2 square 5, 2 square is 4. 4 if you divide by 5, remainder will be 4. 2 cube 8. 8 if you divide by 5, remainder will be 3. 2 power 4 16. If you divide by 5, remainder will be 1. 2 power 5 onwards will be having 32. 32 if you divide by 5, remainder will be 2. Repetition started here. So what we can say, cyclicity for remainders is 4. Right. So what we need to know, 2 power 50 divided by 5 is basically 4 is the cycle, 4 12 48 kabatti. We'll be expressing 50 in terms of 4 there, dividing it by 5. Here also the same thing. After expressing this index in terms of the cycle, if you have remainder, consider remainder. No remainder, we'll consider cycle portion. So as there is a remainder of 2, we'll be considering 2 square divided by 5. 2 square if we divide by 5, remainder is 4. This is the actual way of getting the answer. But if you observe carefully, the advantage that we have with 2 power 50 is what? We can write 2 power 50 as 2 power 2 into 25. 50 we can write as 2 into 25. Avuna? So this is in the form of a power m into n, which we can write it as a power m whole power n, which is nothing but what? 4 power 25. Right or not? And 4 raised to any odd power will always end with 4 only. And any number ending with 4, if we divide by 5, remainder will be 4 itself. So directly what we can say, answer for this question should be choice 4. Using that logic, it is much easier one. Let's move on to the next question. The remainder when 23 power 85 plus 15 power 85 is divided by 19 is. And this, if you are observing carefully, this is in the form of something like x power n plus y power n, where n is what? 85 here. X and y are basically the integers that we are having. X power n plus y power n is divisible by x plus y. There is a rule for this one. When n is odd. Ikkada manaki n ent ochindi? N ichadu 85. So as n is basically odd number, it will be divisible by x plus y. In place of x, what we are having? 23. In place of y, what we are having? 15. That means this number will become divisible by 23 plus 15 and 38. So this number 38 is divisible and then it will be divisible by the factors of 38 also. And if you are looking at the factors for 38, 19 is definitely factor for that one. So that means what we can say, it will be divisible by 19 also. So if this number is exactly divisible by 19, what we can say, there is no remainder. So answer for this question should be choice 1, 0 we can say, right? So knowing that particular point, x power n plus y power n, easy question. The next one, the smallest 5-digit number that is divisible by 22, 33 and 44 is. And if you are observing carefully, the smallest number that will be divisible by the given set of numbers will become the LCM of the given numbers. That is what we can say. So if you are observing carefully, these are all clearly divisible by 2 as well. Most majority are divisible by 2 and all of them are divisible by 11. So if you are considering 11 first as a divisor, 11 2s, 11 3s, 11 4s will be having. So what we can further say is 2 if we take common, 1, 3 is not divisible, leave as it is, 2 will be left out with. For 1, 3 and 2, there is no common factor. So LCM will become the entire outer portion, 11 into 2 into basically this is 6. What we can say, 2 6 times is 12, 12 11 is 132. So basically this is 132 multiple we will be having, and that is the largest 5-digit number we are looking at. And what we can say is largest 5-digit number is what? 10,000. Sorry, smallest 5-digit number is 10,000 because we are looking at smallest. We should divide that by 132. And what we can say, 13 sevens is 91. So 132 sevens will be 924 will be having, right or not? 2 sevens is 14. So we'll be having 924. So how much is left out? 76. That means 760. 13 5 times will be 65. 135 will be 650. 13 6 times will be 780, crossing this value. So that is the reason we cannot go for 6 times. We have to go for only 5 times. So what we can say, it will become basically 660. So how much is the remainder? 100 is the remainder, right or not? So now to get a number which is more than 10,000, which is divisible by the given set of divisors, means we should consider the difference between these two, which is 32, should be added to the smallest 5-digit number. So smallest 5-digit number is 10,000. Daniki manam, if we add that remaining gap of 32, it will become 10,032. So answer for this question should be choice 3. Right. This is the actual way of getting the answer. But if you are observing carefully, this number should be divisible by 22, 33, 44. 22 and 2 and 11. Easy come and 3 and 33 and 3 and 11. 44 ante 4 and 11. So that means it should be a multiple of 4, because if it is divisible by 2 as well as 4 means it is divisible by 4. And in the choices law, 22, what is the divisible tool for 4? Last two digits should be divisible by 4. Last two digits is 22 in this case, not divisible by 4. And here 42. That means straight away these two are gone. And between these two, the number should be divisible by 3. 10,012, the sum of the digits, sum of the divisible tool for 3 is what? Sum of the digits should be divisible by 3. Sum of the digits is 4, not divisible by 3. So that means this is the only number which is divisible by 3. That way it will be much easier to answer the question, right? So in that way, we can focus on this particular question. And the last question, in the next question, in a function hall, 21 yellow chairs, 42 red chairs, and 56 orange chairs have to be put in a row, such that each row contains the same number of chairs of only one color, or one color only. The minimum number of rows in which these chairs can be arranged or may be arranged is the question. So if you are observing carefully, we have 21 yellow chairs. Alane red chairs వచ్చేసి మనకి 42 ఉన్నాయి, right? And orange color chairs వచ్చేసి 56 ఉన్నాయి, right? So వీటిని మనం we have to arrange them in rows such that each row contains the same what we can say chairs of the same color. So that is possible, and that too we have looking at what? Minimizing the number of rows. Right? If we want to have only minimum number with what we can say same number is not there ante, put all yellow in one row, all red in one row, all orange in one row. Manaki 3 rows అయిపోతుంది. But we should have same number of rows also. Same number of chairs per row also. To have that same number also to be satisfied, our number of chairs cannot exceed the HCF of the given numbers. So what are the numbers that we have here? 21, 42, 56. Clearly, if you are observing 7 3s, 7 6 times, 7 8 times, 3 6 8. If you are taking 7 common, those are left out. So what we understand, 3 6 8, they are not having any number which is commonly dividing all three. So HCF will become what? 7, right? So now if you are observing, for each row we have to arrange 7 chairs. Alantapudu, to arrange 21 yellow chairs, what we can say 21 by 7, we require 3 rows for yellow chairs. Alane red chairs ki we require 42 by 7, which will be 6 chairs. And last one, 56 orange chairs ki 56 by 7, 8 rows. So how many rows are required means 3, 6 and 8. Put together 3 plus 6 plus 8. And we require basically 17 rows we can say. Right or not? 6 plus 8 is 14. 14 plus 3 is 17. So how many rows we require for arranging them? 17 chairs. So in that way, we can arrange them, right? So that is the last question that we have discussed. In that way, we can look at, we have focused on the original questions given in the ICET examination of TG as well as AP. And please join our Telegram group. The link is provided here, and you can, already we have saw the videos and for latest updates and the contents pertaining to your preparation, right? To subscribe to our channel, right? Links are given in the description box. And for the classroom coaching, contact our nearest time center, wherever you are staying, contact the nearest time center. And for online coaching, you can enroll on that link that is provided, right? Thank you all of you.